Okay, for our next example of pressure and height, we are going to calculate the pressure at the depth. Okay, so I I did helmet diving before in Boracay. Let me show you. So I think that was 3 years ago. I went to Boracay. I studied there, nerd, right? And of course, enjoy. So I did some helmet diving. So here it is, somewhere beyond the sea. And then the guy told me that, okay, the depth is about 5 meters. So if you do the helmet diving, you can enjoy the fishes. As you can see, I'm enjoying myself there with feeding the fishes. It's an amazing experience. Okay, so the diver told me that the height is about 5 meters. Okay, so below the sea level. So this is the sea level. There are fishes here swimming and you're feeding it. Okay, so here our P2 is at the lower portion, or at the depth, the deeper part. And then P1 is the atmospheric pressure, which is 101.325 kilopascal, or 101,325 pascal. So let's compute pressure 2. What is the pressure if you are at about 5 meters deep if you do this helmet diving? So will the pressure increase? I think it's obvious, right? So at the deeper part, the pressure tends to be higher. The pressure is higher as you go deeper. So if you're going to do the helmet diving, perhaps you can consider if you can tolerate high pressures, because it's annoying sometimes to the ear, and you are using this compressor to deliver the air from the top so that you can breathe. So it's like an astronaut. You can breathe under the water. Okay, so we are going to determine the pressure 2. And the formula is P2 equals P1 plus rho Hg. Rho is the density of the fluid, which is yung salt water. H is the height or the depth, and G is the 9.8 meter per second squared. So we'll just substitute the value. So 101,325 Pascal. I'm not going to write the units, but it's all SI. Okay, plus the density of the salt water, which is 1,026 kilogram per cubic meter, times the acceleration due to gravity, 9.8 meter per second squared. Okay, so the pressure there is actually, you can use your calculator, 151,600, about that, Pascal, or 151.6 kilopascal. So compared it to the atmospheric pressure, it's definitely higher by 51 or 50 kilopascal. Okay, so it's definitely higher pressure. How about at 11 meters? At 11 meters, you can just substitute the height here. You should get the pressure is about 200 kilopascal. So it's twice higher now as compared to the atmospheric pressure, which is about 100 kilopascal. So it's 2 times the atmospheric pressure. So if you go deeper to sea, the pressure increases. Okay, and if you want to do helmet diving, make sure you can tolerate. This compressor also exerts extra pressure because it delivers the air to your helmet. So sometimes it's a little bit annoying, and before you do this, make sure you are in a good health condition, and make sure that you don't panic while you are under the sea, because sometimes it's psychological. The effect is psychological. But also do it slowly, because your body and your ears will adjust to the increasing pressure. So you can thumbs up or thumbs down to your guide to make sure that you're not okay or you're okay. The helmet is also heavy, so you can try it first before go down. It's a little bit heavy, and it will pull you down, okay, or push you down to the bottom of the ocean. Okay, so if you are in Boracay, if you're planning to go to Boracay, you can try helmet diving, but beware. Make sure everything is in good condition, the pressure, the compressor, the guide. Okay, so enjoy learning, guys. That is our last example for pressure at depth.